Somewhere in the universe, there are objects so extreme that the laws of physics begin to feel almost broken. Imagine compressing a star, larger than our sun, into a sphere only about 20 kilometers across. Inside this tiny cosmic object, matter is crushed so violently that atoms themselves stop existing. What remains is one of the strangest substances in the universe. A single teaspoon of it would weigh billions of tons on Earth. These objects are called neutron stars, and what happens inside them is almost impossible to imagine. When a massive star reaches the end of its life, it explodes in a spectacular supernova. The outer layers are blasted into space, creating glowing clouds of gas and dust. But deep inside the collapsing core, gravity wins the final battle. In just a few seconds, the core of the star collapses inward with unimaginable force. The pressure becomes so extreme that electrons are pushed directly into protons. When this happens, they merge together, forming neutrons. The result is a neutron star, an object made almost entirely of neutrons, packed together more tightly than anything we can recreate on Earth. To understand the scale, imagine taking the mass of our sun and squeezing it into a city-sized sphere. The gravity on its surface becomes so intense that a single step would require the energy of a rocket launch. If you somehow managed to stand on a neutron star, which would already be impossible, you would weigh billions of times more than you do on Earth, and the gravity would flatten you instantly into a thin atomic layer. But the surface is only the beginning. Beneath the crust of a neutron star, things become even stranger. The outer crust is believed to contain atomic nuclei, packed together in a lattice so dense that electrons move freely like a metallic ocean. But deeper inside, the pressure grows even more intense. At these depths, matter begins forming bizarre structures known as nuclear pasta. Scientists call them this because their shapes resemble spaghetti, lasagna, and gnocchi. These bizarre structures may actually be the strongest material in the universe. Computer simulations suggest nuclear pasta could be 10 billion times stronger than steel. And yet, even this may not be the strangest part. Deeper still, the boundaries between particles begin to blur. Some physicists believe neutrons may break apart into their fundamental components, quarks. If this happens, the core of a neutron star could contain a completely exotic state of matter known as quark matter. This would be a place where particles no longer exist as individual neutrons, but as a dense ocean of free quarks. But here is the fascinating part. Even our best telescopes cannot see inside a neutron star. Everything scientists know about them comes from indirect clues. For example, neutron stars spin incredibly fast. Some rotate hundreds of times per second. As they spin, they release beams of radiation from their magnetic poles. If those beams sweep across Earth, we detect them as pulses of radio waves. These objects are called pulsars, cosmic lighthouses spinning in the darkness of space. The magnetic fields around neutron stars are also unbelievably powerful. Some neutron stars, called magnetars, have magnetic fields trillions of times stronger than Earth's. A magnetar passing halfway between Earth and the Moon could erase every credit card and disrupt electronic systems across the planet. And yet, despite everything we know, the true interior of neutron stars remains one of the biggest mysteries in astrophysics. Inside that tiny sphere, gravity crushes matter to the edge of physics itself. Atoms disappear. Particles merge. and matter transforms into forms that may not exist anywhere else in the universe. Neutron stars are not just dead stars. They are cosmic laboratories, testing the limits of matter, gravity, and the fundamental structure of reality. And every new observation brings scientists one step closer to understanding what really lies inside them. But one question still remains. If we could somehow journey into the heart of a neutron star, what do you think we would actually find there? Would it be nuclear pasta, exotic quark matter, or something completely unknown that physics has not discovered yet?